Welcome everyone to our statistics series, the JAMB aspect of it. Today we'll be treating measure of spread in bracket variation. That's measure of variation or measure of dispersion. So when we say measure of spread, we are still saying measure of variation or measure of dispersion. This is the degree to which data are scattered or dispersed about its average value. The several measures of spread are the range, mean deviation, interquartile range, variance, and standard deviation. First, we start with the range. This is the simplest measure of spread, or simplest measure of dispersion, or simplest measure of variation. It is defined as the difference between the largest and the smallest number in a given set of numbers. Let's take some examples under range. The range of 4, 3, 11, 9, 6, 15, 19, 23, 27, 24, 21, and 16 is, the options are given. Solution. Range is equals to biggest number minus the smallest. And in this case, we have 27 minus 3, which is equals to 24. Another example. Find the range of the numbers minus 1, minus 5, minus 3, 1, 5, and 3. The options are given. Solution. We must recall that the bigger the number, the smaller its value along the negative number line. Thus, range is equals to the largest number minus the smallest number. In this case, the largest number here is 5 minus, then we introduce our bracket because the smallest number there is minus 5. Hence, we introduce the bracket. And when you open up the bracket, that will be equals to 10. Let's take another example. Find the range of 1 over 6, 1 over 3, 3 over 2, 2 over 3, 8 over 9, and 4 over 3. The options are given. Solution. Let us find the LCM of the denominators and multiply through by it for us to know the biggest value number among the fractions. In this case, the LCM of the denominators here is 6, 3, 2, 3, 9, and 3. Now, having written out the numbers, taking the lowest common factors, prime factor here that can go in there, we take 3. Though we can go with 2, but we take 3 first. In this case, 3, we have 3 divide 6, we have 2. 3 divide 3 will give you 1. 3 divide 2, we bring the 2 down. 3 divide 3, give you 1. 3 divide 9, give you 3. 3 divide 3, give you 1. So we can take 3 again. 3 divide 2, bring the 2 down. 3 divide 1, you bring the 1 down. 3 divide 2, you bring the 2 down. 3 divide 1, you bring the 1 down. 3 divide 3, give you 1. 3 divide 1, you bring the 1 down. Next, we can take 2. 2 divide 2, bring 1 down, it becomes 1. 2 divide 1, you bring the 1 down. 2 divide 2, it gives you 1. Then the rest, you just bring the 1 down. And since we have achieved uniformity, we can say that the LCM is equals to 3 times 3 times 2, which is equals to 18. Multiply through by the LCM, which is 18, we now have that each of the fraction, you are multiplied through by 18. So you have 1 over 6 multiplying 18, 1 over 3 multiplying 18, 3 over 2 multiplying 18, 2 over 3 multiplying 18, 8 over 9 multiplying 18, and 4 over 3 multiplying 18. Our result will be equals to 3, 6, 27, 12, 16, 24. The biggest is 27, and that is 3 over 2. The smallest is 3, and that is 1 over 6. Hence, range will be equals to 3 over 2 minus 1 over 6. And that's the same thing as taking the LCM here. We will have it as 9 minus 1 over 6, which is the same as 8 over 6. That is 4 over 3. Next, we treat another subtopic here, mean deviation. The mean deviation of a set of numbers x1, x2, xn is defined as MD, where MD is mean deviation, is equals to summation, then bar into x minus mean bar all over n. The bar here being absolute value, where s bar is the mean of the numbers, and x minus s bar absolute is the absolute value of the deviation of x from the mean x bar. Next, we take some example under mean deviation. Calculate the mean deviation of the set of numbers 7, 3, 14, 9, 7, and 8. Solution. Mean deviation, MD, is equals to summation of absolute value of S minus S bar all over N. But first, we must find the mean. And you know that S bar is equals to summation S over N. In this case, it's equals to the summation of all the numbers divided by 6, which will give us 48 over 6, and that is 8. Thus, we can now say mean deviation is equals to absolute value. We will be subtracting the mean from each of the values. In the first case, will be absolute value of 7 minus 8 plus 3 minus 8 plus 14 minus 8 plus 9 minus 8 plus 7 minus 8 plus 8 minus 8 all over 6, which is the same as our result will be equals to the absolute value of minus 1, the absolute value of minus 5, the absolute value of 6, the absolute value of 1, the absolute value of minus 1 plus the absolute value of 0, all divided by 6. And that is equals to 1 plus 5 plus 6 plus 1 plus 1 plus 0 all over 6. That will give us 14 over 6, which is equals to 2 whole number 1 over 3. Another example. Find the mean deviation of 1, 2, 3, and 4. The options are given. Solution. Mean deviation, MD, is equals to summation of the absolute value x minus s bar divided by n. But we must first of all find our mean, which is equals to summation s over n. Our mean, which is s bar, which is equals to 1 plus 2 plus 3 plus 4 divided by 4. And that is equals to 10 divided by 4, which is 2.5. Next, we can now say our mean deviation, which is MD, will be equals to absolute value of 1 minus 2.5 plus absolute value of 2 minus 2.5 plus absolute value of 3 minus 2.5 plus absolute value of 4 minus 2.5 all over 4, which is equals to the absolute value of minus 1.5 plus the absolute value of minus 0.5 plus the absolute value of 0.5 plus the absolute value of 1.5 all over 4, which is equals to 1.5 plus 0.5 plus 0.5 plus 1.5 divided by 4, which is equals to 4 over 4. That is 1.0. Next, we treat another subheading, variance and standard deviation. The variance of a set of numbers s1, s2, on and on up to sk is given as v equals to summation of bracket open x minus x bar bracket close square divided by n, where v is the variance and x minus s bar square bracket open and close is the square of the deviation from the mean, while standard deviation is the square root of variance, written as sd equals to also the square root of the formula of variance quoted above. There is a connecting formula between standard deviation and variance. 1. Standard deviation is equals to square root of variance. 2. Standard deviation square is equals to variance. Let's take some examples. The data 3, 6, 2, 1, 7, and 5 has a standard deviation of 2.16. Find the variance of the data. The options are given. Solution. From the relationship between standard deviation and variance, we are told that standard deviation square is equals to variance. So our 2.16 square, which is equals to 4.7, that is our variance. Another example. Given that the standard deviation of a set of data is 3.6, what is the variance of the data? The options are given. Solution. We have already been told that standard deviation square is equals to variance. The square of the standard deviation is 3.6 squared will be equals to the variance, and that is 12.96. How we got our value was that since in JAMB you are not allowed to use calculator, 3.6 squared is the same thing as 36 squared. So you multiply 36 times 36 and you get 216 and 108. When you add their value, one place of decimal square is the same thing as two places of decimal. And you move that, you get that 12.96. It's better explained, better shown in the textbook at page 102. Another example. The variance of the scores 1, 2, 3, 4, 5 is, the options are given. Solution. Variance is equals to summation into bracket open x minus s bar summation bracket close square over n. But first, we find our mean in this case. Our mean S bar is equals to summation S over N, which is equals to, in this case, 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which is equals to 15 over 5, and that is 3. Thus, our variance will be equals to, a bracket open, 1 minus 3, bracket close square. We are subtracting the mean from each of the value. Then in second case, plus 2 minus 3, bracket open and close square, plus 3 minus 3, bracket open and close square, plus 4 minus 3, plus 5 minus 3, bracket open and close square, all over 5. That will give us minus 2 squared, plus minus 1 squared, plus 0 squared, plus 1 squared, plus 2 squared divided by 5. And that result is the same as 4 plus 1 plus 0 plus 1 plus 4 divided by 5. And that is the same thing as 10 over 5, which is 2.0. Another example. Find the standard deviation of 2, 4, 5, 6, 8. The options are given. Solution. We know that standard deviation is equal to square root of variance. So we find our variance, which is variance is equals to summation of bracket open S minus S bar, bracket close, square over N. But our mean, which is S bar, is equal to summation S over N, which will give us, in this case, it will give us 2 plus 4 plus 5 plus 6 plus 8 divided by 5. And the result is 25 over 5, which will give us 5. From here, we can now proceed to find our variance, which is equals to, we will now be subtracting the mean from each of the given values. And in the first case, we have 2 minus 5, bracket open and close square, plus 4 minus 5, bracket open and close square, plus 5 minus 5, bracket open and close square, plus 6 minus 5, bracket open and close square, plus 8 minus 5, bracket open and close square, all over 5. The result is minus 3 square, plus minus 1 square, plus 0 square, plus 1 square, plus 3 square, all over 5. That will give us 9 plus 1, plus 0, plus 1, plus 9 divided by 5, which is equals to 20 over 5, and that is 4. But we know that standard deviation is equals to square root of variance. In this case, it will be equals to square root of 4, which is equals to 2. And 2 is the same thing as 2.0. We've come to the end of the examples under this, our teaching. Next, we have some exercises to cover what we have been taught. Please try your hands on the exercises, which are taken from page 98 up to page 103 of the hidden fact in JAMB mathematics. Please try your hands on the exercises. The answers are provided at the answer section of the text, either the hard copy or the soft copy. Thank you.